This video is going to talk about the difference between speed and velocity. Suppose somebody asked you to describe how fast you were going. You would probably say something like 20 miles per hour, or if we think metric, maybe 15 meters per second. In both instances, if you look at what we've said, miles per hour and meters per second, what we're really talking about here is how far did we go divided by how much time did it take. In math, miles per hour means miles divided by hours. So by looking at the units that we use to describe these things, we can get a really big clue about how we can calculate them. Okay? Now, why do we have two? Why do we have to have speed and velocity? Well, it goes back to that whole how far issue. Because there's two answers to the question how far, either the length of the path we traveled, which was distance, or where we finished compared to where we started with a direction, which was displacement. Because there's two answers to how far, there's two answers to how fast. So one of these two quantities is going to be about distances, and one of them is going to be about displacements. So let's look at it a little bit more closely and compare how they're similar, and maybe more importantly, how they're different. So we'll start with speed. Speed is a scalar quantity. That means it's just a number, 15 meters per second. I don't care which direction I'm going. All I care about is how fast. So when I talk about 15 meters per second, that's a speed. The symbol for speed is not what you would probably expect. Most of us would like to write the letter S for speed, but in the rest of the world, and we are part of the world, the letter S stands for something else, so we can't do that. So what has traditionally been done is we use the letter V for speed. Now I know that sounds funny because V would go a lot better for velocity. Well, you're going to find out that in fact V does also stand for velocity. So we're going to have some way to distinguish between speed and velocity, and we do. So we might as well get used to it. V, the letter V stands for speed. The definition, because speed is a scalar, we use distance when we calculate speed. So we would say speed is distance over time, meters per second. Now over is another way of saying divide. So we wanted to write an equation for how to calculate speed. We would say speed is the distance divided by the time. Now, you may not recognize what I've written here as distance divided by time. We use the Greek letter delta, that's the triangle, to represent changes in things. So what we would say here is delta x, the change in position. When it's a scalar, we call distance. Delta t is how much time it took, the change in time from when we started to when we ended. All right, so v equals delta x divided by delta t is the same thing as saying position change divided by time. All right, so let's write this down about delta. Delta is a Greek letter. It means change in. And when we calculate changes, we always take the ending value minus the starting value. Okay? So we'll have to remember that. We're going to get lots of practice doing this in just a minute. So right now, all we're doing is writing down what we have. All right, so velocity. Velocity is different. It has to be. It's a different thing. So if speed is a scalar, velocity is a vector. The symbol for speed was V. I said the symbol for velocity was V. So how do we show that it's a vector? We use arrows to define vectors, so we draw an arrow over the V for velocity. And that's how you tell the difference. A V without an arrow means speed. A V with an arrow means velocity. Now in your textbook, what they'll do instead of putting the arrow on top of it is they'll make the vector be a bold letter and the scalar be a regular letter. So you might get used to seeing that in the textbook. All right, the definition of velocity, because velocity is a vector, the how far we want is not distance, it's displacement. So velocity is displacement over time. Remember, displacement requires me to say what direction, and displacement requires me to know where I started and where I ended, but it doesn't care how I got there. Speed is about the path, velocity is about where did I go. The equation for calculating velocity looks a lot like the equation for calculating speed, with the addition of the vector arrows. So the velocity vector is the change in position vector, displacement, divided by the amount of time it took. The symbol delta still represents change, and we still do our last value minus our starting value. So that, in a nutshell, is what speed and velocity are. Now, how do we get the information that we need to calculate these things? Well, quite often we're going to have graphs to look at. So here's an example of a position and time graph. You have lots of practice looking at these things, so we could say, without doing any calculations, and before we start this unit, in the first 4 seconds, this thing was moving forward. We know it's going forward because the line on the graph between 0 and 4 seconds goes up. It's a straight line, so we would define this motion as steady or constant motion. From 4 to 8 seconds, we see it turned around and came back towards the origin. Again, steady and constant. From 8 to 12 seconds, it turned around and came back some more. But this time, the line's a little steeper, so we probably have some idea that maybe that means it was faster. But we'll find out in a minute. From 12 to 16 seconds, we went forward again, and we went a lot forward this time. So that line's even steeper than the other ones. And then for the last 4 seconds, from 16 to 20, we came back again. We know we're coming back because the line on the graph is going down. Okay, so suppose I want to calculate the speed for the first 4 seconds. In order to do that, I need to know the distance I traveled for those 4 seconds. I need to know the time it took. All right, so how do I find distance when I look at this graph? Well, distance is how far up did I go. So how far up does the graph go from 0 seconds to 4 seconds? Well, it looks to me like it starts at 10 meters and ends at 30 meters. So that would be up positive 20 meters. All right, so that part of the graph goes up 20 meters. That would be my distance traveled. So if I want to find my speed, I need distance over time. So speed equals 20 meters is my distance over 4 seconds. I solve for my speed, I get 5 meters per second. So in the first 4 seconds, from 0 to 4, we traveled 20 meters in 4 seconds. My speed is 20 divided by 4, 5 meters per second. Hopefully that's nice and clear and makes some sense. Okay? Now, let's look at another example. Same graph, we're going to do a different calculation. All right, so here's the same graph again. This time, let's find our speed for the first 12 seconds. So what do I need to know to find the speed for the first 12 seconds? Well, I need to know how far I traveled, right? So again, for the first 4 seconds, we already did that. That was 20 meters. No problem there. How far did we travel between 4 and 8 seconds? Well, we went from 30 down to 20, so we traveled 10 meters here. We went down. And then for the last 4 seconds, we went from 20 down to 0, down again, 20. Okay, now, I need to know distance. Does distance care whether it was up or down? course not. You remember from the previous unit. So really, for distance, I don't care about the pluses and minuses. I just look at the numbers. And so my distance traveled for the first 12 seconds is going to be 20 plus 10 plus 20. Distance traveled is 50 meters. How much time did it take? Well, we started at 0 and ended at 12, so I do my change in time, 12 minus 0, and that gives me 12 seconds. To find my speed, I do my distance traveled divided by my time. So distance over time, 50 meters in 12 seconds. Oh, let's see, 50 divided by 12, that's 4.17 meters per second. So for the first 12 seconds, my speed was 4.17. Now you look at the graph and you say, wait a minute, 4.17 meters per second, we were going fast here, a little bit slower, maybe even a little bit faster, and maybe even a little bit faster. How do we come up with one number for these three different things? All right, well, this is another interesting part of physics. When we pick intervals of time like this and we look at the graph and we figure out distance or displacement and calculate these speeds and velocities, what we're really saying is, suppose we started at 10 and suppose we travel 50 meters in 12 seconds. How fast do we have to go at a steady rate to get there? Okay? We call this an average value. It's not an average like you do in math, where you add up three numbers and then you divide by 3 because you added up three numbers. This is an average because it represents the one constant steady speed that we could travel to get to the same distance in the same amount of time. So when we calculate these values, what we're calculating are called average speeds.